To our presentation on emotion decoding from textual corpus through advanced natural language processing, conducted at Gokraju Rangaraju Institute of Engineering and Technology. Under the guidance of Assistant Professor A. Pavitra ma'am, our team members, myself, Sai Venkat, and other members are Bharat and Aravind. Abstract. Emotions are a challenge, which I wanted to mention it in the beginning itself. So we are trying to make it possible through the textual data, which is given by the user through maintaining it into a natural language processing model, or actually the technique which we want to implement, and we have succeeded in it, and we'll further look into it. So basically, abstract just wants to maintain that we are we are predicting the emotion through textual data which is given by the user. That's it. So our aim is just to analyze the emotions which are given by the user appropriately using the pre-processing techniques, and mainly the model's accuracy as well as its performance based on the new versions. So scope to have a future sight in the artificial intelligence era using generative AI therapy as well. So this is our future scope, and existing systems are sentimental analysis, which are famous for companies which are leading companies, Brand 24 and Talkwalker. They does they do sentiment analysis just on the commentary on given by the twitters. Basically the Twitter sentiment analysis is famous, and as well as the Amazon sentiment analysis, in which the sentences or the comments given by the users are taken into the consideration to make the prediction overall to a product or to a company or to an organization or to an institution. So our proposed system to be, basically, we want to implement a project with more than six labels. That is independent six labels: sadness, love, joy, fear, and anger. So in when we are doing a project, we could implement eight labels as well. So that was our proposed system, and we concluded with eight labels in totally. So before system was only maintaining only three levels, that is positive, neutral, negative, but we want to clearly mention that which emotion does the user want to convey through his text. That was our proposed system. Next, the use case diagram properly mentions illustrates the use case diagram for our proposed system, highlighting different interactions between the users and the system. It shows how users input textual data and receive emotion classification results through the main features of the model. A class diagram. Typically, the slide presents the class diagram detailing the structure of system and the relationships between the different classes. So each class is not independent. They are dependent to the main class, that is the emotion classifier app. Sorry for this congested picture, but still I can make you to understand that we have five different main levels, that is the database handler, model handler, preprocessor, calculator, visualization. So basically these I have divided into five different types of functionalities. So they have divided into five classes. So database handler manages all the databases and it's the total data. Model handler is to maintain the pre-trained data trained model to maintain the accuracy and performance at any point of time when it get trained. Data preprocessor totally preprocesses the text. Metric calculator, it helps us to maintain the accuracy, etc., precision, F1 score, other metrics. And visualization is totally about plotting graphs and scatter plots, etc., mainly training and validation accuracy graph and the confusion matrix. The activity diagram. Here with the activity diagram, we shows the workflow of a system and the sequence of activities involved in emotion detection from textual data. It includes steps like data input, pre-processing, model training, and classification. In the sequence diagram on the slide outlines the interaction between different system components over time. Ensuring a clear understanding of the process flow, it details the sequence of operations from receiving input text to deliver emotion classification at the final step. So mainly the architecture helps us to understand the total system, how our project works. So the front end is basically the interface which is maintained with the user, that is the home screen and the predictions which the user can able to see after his prompt has been submitted successfully. And the analysis metrics are also a part of our front end page where he needs to switch the tab. So we'll be detailedly looking into the project when it comes to that. So in the back end, we are just maintaining the loading the model. So this is a important fact that we are loading the model each and every time to maintain its accuracy every time. So the model loading is happening every time when the user is opening it. So, and I also want to convey that the model is pre-trained, as well as it can be trained once again to make sure that it gets a good accuracy if at any point of time due to any server issue, etc., we have given that feature to the user as well. So calculates probabilities, and these are some features of our backend tool. So we can detail look into it in its subdivisions. That is monitoring and logging is basically the database. The database, I mean the database which maintains the information. The monitoring information is the basically the user gives his input and the label which has been predicted. We do not leave it simply. We take those input and the predicted label and store it into our own database, which we can see in our code where we have implemented it. So monitoring is basically that purpose. Logging is the purpose where when the user has come, what is his timestamp at the time, or where how many times has been interacted with on a day or a month on a year. So we can maintain the logging purposes on this in the database. Basically the page visitor table, so how many times the user has visited the table, and the prediction details. So what about the user, what he got, the predictions, what predictions he had got from his prompts. So we can simply view that as well, view that and take it into a maintain it into a database through the SQLite technology. So model performance metrics are not stored, but still we maintained it. Like if the accuracy is getting low, but still we wanted to tell that the accuracy is not low, so with that we can maintain it in a database as well. Model management is totally based on the loading data, training the model, evaluating model. We can detailedly look into the code. So we'll just move ahead. After the model registry is nothing but just it stores the model versions. Basically if the version has been like upgraded, the version we can implement the new version of the model directly, instead of making other features unable to implement that. We can simply just upgrade our version without any inconvenience caused for the features which are already present in this project. This is our most important aspect. So let us get into the implementation part. In implementation, these are some application dependencies which are used for maintaining the projects, detailed structures, etc. So basically, Streamlit is used for the web. So we can just brief it up. Pandas. So these are the common libraries which we use to take manipulations or any kind of things we can use. So that's purpose. Datetime is just simply to make the timestamps. Sklearns is as usual because the models we need to maintain it. So we need to implement sklearn. So SQLite 3 is the technology we wanted to use, the SQL technology. So context lib is just the I said the store manager, the model registry which we have just seen in the architecture. That the purpose of it. The SciPy, Cbon, and Matplotlib. These are the functions. These are the libraries which can be help us to maintain the visualization of the techniques. So in that's it. We can just continue. So this is the database handling features. So basically the database get DB connection is simply to connect the database with the existing existing project or the existing time when the server is loaded, and create page visitor table. This helps us to make the page visitor table at and each hour or each day or each month we can just maintain it as our we wish. So this helps us to maintain the record of the user which we wanted to keep in our database. So add page visitor details. So this sorry the create page visitor table just helps us to maintain the table, which basically which creates the table. Add page visitor details helps us to keep the record or keep the details of the user in the database. View all page listed details. It can be just to maintain, retrieve the data any point of time. It can be used. Create emotional CLF is just an emotion classifier. Like basically, we have eight labels. So eight labels independently. How many users have got this predictions, etc. That's the point. And these are also the database handling functions. Add prediction details. The predictions which are made by the user will be added into a separate data table. Sorry, table. All prediction details. The prediction details like the count of each prediction, how many times of the, this has been occurred. So we'll be getting that details here. So this is the totally the model which we are implementing it. The load model, the model we have implemented this is the multinomial logistic regression model, which is very famous. Basically, we have chosen this as this as our model because to everyone are trying to make out like how this emotion is classified into in these three labels directly. But we have come up with an idea why we cannot try to make like we have eight labels. So for each label, what would be the prediction probability if we choose it as a choice? So we have maintained each prediction probabilities, and finally we have converted the best probability prediction which has been done as the emotion detected for the given input. So that is our strategy which we have used here. The model prediction emotions nothing but just loads the model. Predict emotions is the function which we have used to predict the emotions as well. And the get prediction probability is the function which helps us to get the probabilities of each emotion. Like for eight levels, we get the eight level emotions. That's it. Next, in retrain model, I have just that we have added a feature to retrain the model once again for if at any point of time server issue etc. we can just retrain the model once again. These are some accuracy metrics which we have just implemented in realistic accuracy. I just wanted to maintain the realistic nothing but just to maintain the accuracy. That's it. Load data set, it loads the data. Calculates metrics, these are the metric calculating functions. That's just we need to implement and keep the y prediction. That's the just nothing but implementing the functions and giving the inputs which we have got as a prediction. Or sorry, basically just we will be giving the inputs, that is the y test and the y prediction details. So we'll matching and we'll getting the respective scores. Flux nothing but plot accuracy graphs is nothing but just to maintain the visualizations. And confusion matrix is the this is the training and validation accuracy above one. This plots the confusion matrix results. So this is our home screen. This is the tab which we have implemented to make it home to display the home screen and the analysis screen. About is nothing but just to maintain the project's description. This is the main page, and this is our sample prediction. The user can give the prompt, and when he submits, we'll get the text what he has given, original text, and the prediction. So we can just confirm it by seeing the prediction probability graph. So whether we have got a good whether we have got the correct prediction based on our model. That is, for each prediction, it gives the probability based on the graph. We can see through the bar chart whether here we have the shape probability as the highest, so we got the prediction as it is. We get the confidence as well. So the confidences are measured on the y-axis. The x-axis are the eight labels totally. Analysis, this is our training and validation accuracy graph. We got 95% accurate, more than 95% accuracy all the time. So other scores are also the same, nothing to worry. And the confusion matrix is where basically which conveys the whether we got what inputs we have, what predictions we got uh, for the given input, for the given input. Like if the predicted level is anger and the given level is disgust, so no point in making the model. So we have checked, we using the configuration matrix. So we are luckily we are getting less errors. So by training it with more epochs, so we may get it into binary matrix. So this is the confusion matrix. Thank you. um, So here we can just give the input. We can give any kind of input. So let us say that yes, hi, I got a chance. I got a lucky ticket for which I got a new bike. So this is a realistic data which we have taken. So basically, I got a lucky ticket. Since I got a lucky ticket, it is predicting as a new neutral. If we take it as somewhat okay, we'll take it another input. My mother gave me 100,000 rupees for my good grades. Joy. Since it's an emotion which is universally true, where we get a joy as an emotion, like we are very happy at the time at that point of time. So it's a universal emotion, and absolutely in a realistic data as well, we'll get the joy as a predicted emotion. So this is a sample predicted output, and this is the live execution, and this is the analysis. So accuracy is somewhat 99 point something. So precision, these are the scores which we get for the model when we got trained. The confusion matrix is this is a live data. This is not a pretend. This is a live data. We can just, if you want, we can just return it the model, but it takes somewhat a 2 minute time. So it gets trained once again. The total data is run. After that, we get the new accuracies, precision, recall, F1 scores, confusion matrix, everything. We'll get the new graph as well. We'll just wait for 1 minute. So we have got this graph. It shows that 98.65% accuracy, precision is high, recall, F1 score, everything is high. Confusion matrix is less than 5. Each number is less than, sorry, 6. So basically, it's a good confusion matrix. No need to worry much. Done. Thank you. Thank you for giving this opportunity to show my project with a live demo as well. Thank you.